Welcome to my video on conjugate of a complex number. A quantity that becomes useful in the work with complex numbers is called the complex conjugate. In this video I want to show what that is and how you determine what it is and some of the applications you can use it in. So first of all, let's just go back to our basic definition of a complex number. C is equal to a plus bi, where I is the square root of minus 1. That's a complex number. Now the conjugate, and we can designate this by a line over the top or a star, or some people do another, maybe a little cross, or we can put a line over the top. And so that designates that as the conjugate of a complex number. And really it's super simple to create the complex conjugate. You just change the sign. Instead of a plus bi, it's a minus bi. It gets a little more involved in that as we go on, but that's really what the bottom line is about converting to a complex conjugate. A simple example would be like z is equal to 2 plus 4i, z star, or z hat, or even z cross, whatever you wanted to call it, is 2 minus 4i. We just change the sign. So that's a simple way to create a complex conjugate. Next, we want to look at properties of the complex conjugate. The product of a complex number and its conjugate is a non-negative real number. So here is our complex number in standard form. Z is equal to a plus ib. This is the number times its complex conjugate, and we're going to show that that's equal to a squared plus b squared. So it's just the real part of the complex number squared plus the imaginary part of the complex number. So let's do a little proof of that. We're going to multiply these together, and we're going to use the FOIL method. So we've got first, which is a squared, outer, minus abi, inner is abi, and then last, which is these last two, that's minus bi squared. Well, these two middle terms go away, so we're left with a squared minus b squared I, and that's really going to be I squared. And so I squared is minus 1, so we're left with a squared plus b squared. So, and this z times, or the imaginary number times its conjugate, is called the magnitude or the modulus of the complex number. Now let's do an example. So we're going to give the number, the complex number times its conjugate. The complex number is 2 plus 3i times the conjugate 2 minus 3i. So just doing our first, outer, inner, last. First, 2 times 2. The outer is minus 3 times 2i. The inner, which is these two right here, is going to be plus 2 times 3i. And then the last, which is going to be these two right here. And that is going to be just 3 times 3. That's going to be minus 9i squared. Okay, so we can simplify this. These two terms right here are going to drop out because it's plus and minus the same thing. So we're going to get 4. And then we're going to get I squared is minus 1. So that's 4 plus 9. And that is going to be the magnitude, or z times z star. And we go back to that formula we developed a while ago. Z times z star was just a squared plus b squared. Okay, in this case, a is 2 plus b, which is 3, quantity squared. So we did two methods here. We used the formula right here, got the same number, which is equal to 4 plus 9, or we did it the FOIL method, where we actually multiplied the two complex numbers times each other. Next, let's look at the reciprocal of a complex number. So it's just 1 over. And we're going to use this in the division of complex numbers in a future video, so it's a good thing to learn because it makes division doable. To express the reciprocal of a complex number z in the standard form, so note, in the standard form, multiply the numerator and denominator by its conjugate. So this is 1 over a complex number, a plus bi, which is really just 1 over z. So this rule tells us we multiply the numerator and the denominator by the complex conjugate. So that becomes z star on the top, or z conjugate. Now we just worked out what z times z conjugate is. That's going to be equal to a squared plus b squared. So we know the numerator is just the conjugate, that's a minus bi. So now we can do a little algebra. So this is going to be the real term of it, and this is going to be the imaginary term because here's the I factor. So that gives us the standard form of a reciprocal of a complex number. All right, let's do an example. Let's find the reciprocal of 3 plus 4i in standard form. So we've got 1 over 3 plus 4i. That is going to be equal to 1 over 3 plus 4i. And we're going to multiply by the complex conjugate. So that's 3 minus 4i over 3 minus 4i. So that's going to be what we're going to work with. Now the numerator just becomes 1 times 3 minus 4i, and the denominator is 3 plus 4i, 3 minus 4i. Now we can either do this the easy way or the hard way. The easy way tells us that we know that this denominator here, which is z times z star, is just going to be a squared plus b squared, which is 3 squared plus 4 squared, which is 9 plus 16, which is equal to 25. So the denominator is 25. So now we get 3 minus 4i over 25. We can rewrite this as 3 over 25 minus 4 over 25 times I. So there's our answer. Well, I hope you got something out of this video, learn a little bit about the reciprocal and the complex conjugate of complex numbers. If you did, give me a like, thumbs up, subscribe to my channel. Thank you for watching.